Okay, now for example number 7, we want to find the center of mass of a semicircular plate of radius r. So take a look at figure 14 here. We have a semicircle with a radius over here is negative r. It's going from negative r to positive r. And we have y, which is equal to the square root of r squared minus x squared, which is defined by the formula for the circle. So in order to use equation 12, we have to place the semicircle as in figure 14 so that f of x is equal to the square root of r squared minus x squared. And the lower limit is negative r, the upper limit is r. So here there is no need to use the formula to calculate x bar because by the symmetry principle, the center of mass must lie on the y-axis. So x bar is equal to 0. The area of the semicircle is equal to 1/2 pi r squared. So y bar is equal to 1 over a going from negative r to r times 1/2 of f of x squared dx. So the area now becomes 1 over 1/2 pi r squared. Factoring out the 1/2 from the formula times 1/2, going from negative r to r times the function, the square root of r squared minus x squared squared. Now, since we know that the area on the left side is going to equal the area on the right side, then we can then multiply the entire integral by 2, and then now go from 0 to r. And now that becomes r squared minus x squared dx. So now if we evaluate and take the antiderivative of those two terms, we would get 2 over pi r squared, evaluating it as a lower limit from 0 to r, which then gives us 2 over pi r squared times 2r cubed 3 over 3, which is equal to 4r over 3 pi. So therefore, the center of the mass is going to be located at the point of 0, which we know that that's represented x bar, and the y value becomes 4r over 3 pi.